All right, we begin our 13th topic of the semester, linear inequalities and then systems with those linear inequalities. So, difference in inequalities and equalities are that there still can be no solution or infinite number of solutions, but technically, if we're dealing with systems of inequalities, there could be infinite number of solutions a lot of times. And one solution is usually not the case when you're dealing with just a single inequality or a system of inequalities. So that kind of is the big difference in the two. So, but a lot of the things that we learn for linear equations is the same for linear inequalities. We just got to add a few little things, review those things, and get going with that. So the first thing we want to talk about is determining which points satisfy an inequality. So to satisfy an inequality, what does it take to satisfy an equation or an inequality? Not necessarily. Not always. Do you have to get y by itself? That doesn't. What does it take for an ordered pair to satisfy an equation or an inequality? It has to be true, right? So if it's an equation, you put the x and the y in there, and it works out to be the same number on both sides. With an inequality, you put the ordered pair in there, and it works out to be a true statement. It may not be the same number on each side, but the inequality symbol allows it to be a true or a false statement out of that. So looking at this problem, we have one inequality, y is greater than or equal to negative 2x plus 9, and then we have three ordered pairs, and they want us to decide which of those points, if any of them, would satisfy that inequality. So what we've got to do is just plug in the ordered pairs into that inequality and see if it works. So for A part, you're going to put a 4 in the place of y and a 7 in the place of x. And we're going to work out the side that has work to do on it. So that's negative 14 plus 9. So is 4 greater than or equal to negative 5? Is that true or false? Yeah, it's greater than, right? So yeah, that's true. So this one checks, it works. So that's going to be an ordered pair that satisfies that. Let's check B and see if it works out. 3, oops, didn't mean to flip the symbol. Greater than or equal to negative 2 times negative 1 plus 9. So that's going to be 2 plus 9. Is 3 greater than or equal to 11? No, that's false. So that one's out. Let's check C and see if it works. Maybe more than one of them that works here. So plugging in negative 5 for y and 10 for x. It's going to be negative 5 and negative 20 plus 9. Negative 5 greater than or equal to negative 11. That's also true. So we end up with two of these working here. I can imagine on EOC or the benchmark that we'll have coming up toward the end of this month is when the first benchmark happens. End of this month, first of March, our first benchmark will happen. I can imagine them having like one of those multiple choice that you got to check more than one of them. How many of these work for the answer, and you have to check them all to see. So I can envision that being that kind of problem there, that you would pick more than one for an answer there. All right, so let's get to a word problem. Everybody's favorite. Y'all love these. Every class I've ever had loves word problems. But we're going to try to take this idea and with an inequality and write it a linear inequality for this single situation. So one situation, we got John. He's selling T-shirts, and plain shirts cost $5, and graphic shirts, something with print, some sort of print on it, cost $7. In order to match his product cost, he must make at least $1,200. Okay, so what we want to do is write an inequality to represent this situation. So I'm going to say 5p plus 7g What does the P stand for? No. Plain shirts. G, graphic shirts. The 5 is how much a plain shirt costs. 7 is how much a graphic shirt costs. Now, here's where we got to get the inequality. We know it's going to be 1,200 on the other side here. Well, not 12,000, but 1,200. He's making 12,000. He's doing good with t-shirts. So at least, what inequality symbols or symbol means at least? Greater than or equal to, because at least means the least amount of money that I want to make is 1,200. That breaks me even. I want to make more than that out, honestly, because I want to make a profit, right? So at least, greater than or equal to, at most would be what? Less than or equal to, and that'd be a situation like if you were trying to cut down on how much you had, or that was the limit on how much you had to spend, you'd say an at most type problem. So at least is greater than or equal to, at most, flip it around, that's a less than or equal to. Right? So make sure you know those words. That's an important part. So we've written this inequality for that, and it says if he sells 150 plain shirts and 60 graphic shirts, would he be able to cover the product cost? What do we do with those numbers? Plug them in for each of those things. So it's going to be 5 times 150 plus 7 times 60. And the question is that greater than or equal to 1,200? So 5 times 150 plus 7 times 60 is 1170. Is 1170 greater than or equal to 1,200? No. So would he be able to cover his cost? No. Final answer there would be no, he can't. So B is just like the first example that we did, it's just mixed into a word problem. And we had to write the inequality first. So nothing you're going to have to do in a word problem is going to be very far off from what you're doing with a regular inequality. Okay, so everything you're doing with a regular inequality, likely going to have to do inside of a word problem. All right, C part. If he sells 90 graphic shirts, what's the minimum number of plain shirts he must sell to break even? So breaking even means minimum, that's $0 in profit. But we're breaking even. We're not in the hole. So where does the 90 go? Multiplied by that 7. So we don't know how many plain shirts we're selling, but we know that we've sold 90 graphic shirts. And maybe that's all we had, or some reason 90 is the stopping point on the graphic shirts. And now we've got an inequality here that we can solve to get the plain shirts out of this. How many plain shirts we need to sell. So we multiply 7 times 90. It'd be 630. And then how do I solve that? Subtract that 630 from the 1,200. $570. Divide by 5 is the last step. How much? 114. Good job. So we need to sell 114 or more, right? So 114 plain shirts. That's the minimum number. If we sell 120, what have we done? Made a profit. That's what we're getting out of that. So with that word problem out of that. So nothing too the word problems that you're going to encounter shouldn't be too strenuous. Don't overthink them. That's the easy thing to do, is you want to make them, your brain just wants to make those word problems hard, but they're not too difficult. So the next thing that we want to talk about is graphing a linear inequality on the coordinate plane. So got some grids already drawn there, and we're going to graph these. And what form is number 1 already written in? Slope-intercept form. And that's the form you want it in to graph by if at all possible. So where do I start with this one? The y-intercept, which is -1. And then we're going to do our slope up to over 3. I'm going to do it twice, up to over 3. All right. Now, here's the difference in an inequality and a regular equation. We have to decide what kind of line that is. Y'all remember how to do that? Dotted or dashed or solid line? Which one should it be? And okay, that's right. That's the thing you got to look at. So if it has an equal to, it's going to be what kind of line? Well, they're all straight lines. It's going to be solid. It's so an equation has an equal to mark, right? So it's a solid line. Inequalities, if they have an equal to mark, they're going to be a solid line as well. This one does not have that, so it's going to be the dotted line or dashed line, whichever one you call it. And I'm just going to draw that dashed line there. And then we're not done with that. Do y'all remember what else you have to do? Yeah, you got to do some coloring. Oh, bless your heart. I don't like coloring either. My oldest son hates coloring. But it's something we've got to do. So how do we decide whether to color this side of the line or that side of the line? Not necessarily. All right, so I'm going to teach you how I do it. There's some people teach you different ways. This is how I teach it. I teach pick a test point. Pick you an ordered pair that's on one side of that line. I'm going to pick this point right here. What is that ordered pair for that little red dot? It's the origin. It's 0, 0. Okay? I'm going to plug that in to my inequality that I graphed. I'm going to plug in 0 for y and 0 for x. Work that out. And then we look at that and say, okay, it works out over here. The 2/3 goes away. So it's -1. Is 0 less than -1? No, that's false. So that means this side is false. And if that side is false, the other side's got to be true, right? So you shade the true side. So your shading is going to go on this side. Always shade the true side. That test point just needs to be on one side of the line or the other. I picked 0, 0 because it's easy to plug in. Technically, you could pick one of these points way up here if you wanted to plug one of those in. But we always try to make it easier on ourselves, right? Pick the easy numbers. It doesn't matter which test point you do as long as it's on one side of the line. It can't be on the line. That's the only restriction on the test point. It doesn't matter which one you pick, as long as it's on one side of the line or the other. And then always shade the true side. Always shade the true side. So let's look at number 2. Y is greater than or equal to -4x. What's the y-intercept for that one? 0. So I'm going to go to 0, 0 and put my dot. And then the slope is -4. So I'm going to go which way? Down 4 over 1. Down 4 over 1. Solid or dotted line? Solid this time because it has what? Equal to mark. Equal to mark means solid line. There's my solid line. Now I need to get a test point. Can I use the origin again? No, the line goes through it, so I got to pick something else. So make it easy on yourself. I'm going to pick that point right there. 1, 1. Why am I picking that one? It's easy, and I can't screw it up when I put it in to the inequality, right? Because if both numbers are the same, then I can't mess up putting them in the wrong spot. So is 1 greater than or equal to -4? So this side is true. So that means I'm going to shade the side my test point is on this time. Because that's true. Does that make a little bit more sense, folks that said they had trouble figuring out how to shade the thing? Just takes a little bit of practice, but the test point is, to me, a foolproof way of doing it. that if you're picking a point, if it's true, shade that side. If it's false, shade the other side. It's always going to work. When we get later on in the course, we'll do some nonlinear inequalities, and test points really the best way to do that as well. So that's why I do it this way. You may have been taught other ways, but this is my way. All right, let's look at number 3. We won't do all of these. 3. What needs to be done to 3? Needs to be put in slope-intercept form. So I would subtract 5x. There's 3y less than or equal to negative 5x plus 12 divided by 3, and I get y is less than or equal to negative 5/3 x plus 4. What? When would I need to flip this symbol around? If what was negative? If I divided by a negative, the number that I divide by was a negative. That negative 5 doesn't matter. It's all about what you divide by or multiply by. Flips that symbol around. So now we can graph this. We go to 4, then we go down 5 over 3. Solid or dotted? Solid again because it's got the equal to mark. That's nice. I can check 0, 0. Does it matter whether I plug that into the original problem or the slope-intercept form? Same answer either way, so it doesn't matter which one. I'm going to go to this one. And is 0 less than or equal to 4? Yes, so that means I would shade this side. I got lazy and did that instead of highlight. Shade that side. Okay. Not too bad, pretty easy to do. Let's do number 4, and then we'll do number 6 after that. So let's do number 4. What should I do first for number 4? Subtract x. Negative 6y is less than negative x minus 12. Divide by negative 6. Yeah, it will flip that symbol because we're dividing by negative. So that's 1 over 6x plus 2. Be careful of that. It's very easy to forget to flip that symbol to get the right inequality to graph. So I'm going to go to 2 up 1 over 6. 1, 2, 3, 4, 5, 6. Y not equal to. I usually will do 2 dots on each, or 1 dot on each side. Makes my line look a little bit better when I draw it. Y'all may be better at it than I am. And then, can I use 0, 0 as my test point on this? Yeah, is 0 greater than 2? Greater than 2. That's false. So I'm going to shade above that line. Again, the shading is the whole graph is your answers. Every one of these ordered pairs that's shaded here is a solution to that inequality. That's what the shading shows us, is that all of these ordered pairs. So technically, for this inequality, there's an infinite number of solutions to that. It's all of these ordered pairs that are in the shaded area. When we get to systems in just a second, we're going to have the whole graph is your answer. Okay, you got to have the graph for your answer for that. Let's look at number 6. The one's a little special. X is less than negative 4. What kind of line does X and a number give us? Horizontal or vertical? Or both? Vertical. X in a number is vertical. Y in a number is going to be horizontal. So this one's going to be vertical. I'm going to go where to make my vertical line? The negative 4 on the x-axis. And is that going to be a dotted vertical line or a solid vertical line? Dotted because it does not have the equal to mark. So 2, 3, 4. We'll make a dotted line through there. A little tough to see, but it's there. Now, shading. This one's actually easier. You don't really even have to do a test point. Where are the x's less than -4? To the left or to the right? To the left. So the shading all goes to the left of that line. So all of these ordered pairs that are to infinity to the left are solutions to that particular inequality. Questions, concerns about these things? Nothing too strenuous about this. This is good old Algebra 1 or 8th grade math again. So I haven't done much. Let's do a word problem that deals with these things. So similar to was example 2 that we did the word problem with. Similar idea. We're going to write an inequality, and then we're going to use this graph to help us decide some things. So Stephanie spends 10 cents per text message and 25 cents per picture message on her cell phone. Her monthly budget for messaging is $30. So what's that mean about a budget? $30. That's the maximum. She can't go over that. So mom says I'm putting $30 is all you get to spend on those things, and you can't go above that. So inequality for that text messages. Well, let's use. I'm gonna use X for text. So 10 cents for text messages plus 25 cents for picture message, and I'm just going to use Y because X and Y go together. And then what should we be to the $30? Very good, Kelly. Less than or equal to. We can't go above $30. That's all we've got for our account there. So going less than or equal to $30. And then it says write that inequality and then graph it. So we're going to graph that. So if I'm going to graph that, what do I need to do? Get Y by itself. So subtract 0.1x. That'd be 0.25y is less than or equal to negative 0.10x plus 30. Divide by 0.25. So that gives y is less than or equal to, and then I don't know, 0.1 divided by 0.25. Math, enter. 2/5. So that'd be negative 2/5 x plus, and then 30 divided by 0.25. 120. Get some classes around here. So have somewhere to be. All right, now here's where the word problems kind of can give you some problems. Look at those numbers. You got 2/5, and then 120 is my y-intercept out of that. So my y-intercept's a really big number, but my graph's not that big. And you probably can't buy a piece of graph paper that goes that big, right? So what do we need to do with our axes here? We want to change the scale, right? So it'd be probably a pretty good idea. Let's see how many we got. How many blocks we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15 blocks there. Go by tens maybe on the y-axis. That'd make it easy to plot, right? And if I go by tens on the y-axis, if I go by tens on the x-axis, then make it easier to do. So I'm going to go by tens. So I'm going to write on my graph, I'm just going to write a x10 and a y10 on there. So that just tells me what you're doing with your axis there. And then go to 120, so 10, 20, 30, 40, 60, 50, 60, 70, 80, 90, 100, 110, 120. So there's my first dot. And then down 2 over 5. Because I'm going by the same scale on each one, I can count 1 to 1. So down 2 over 5 is like down 20 over 50. It's the same number. And then I could graph that. And should this be a dotted or solid line? Solid. Where would the shading go? Above that line or below that line? Well, if I plug in 0, 0 for X and Y, that's legal to do. That'd be like if I used 0 text messages and 0 picture messages. I was grounded for a month, didn't have my phone, right? Couldn't use it. So that'd be 0 less than 120. That's definitely true. So I'm going to shade below that line. So all of these points are possibilities for meeting the requirement. We can't go over $30 in either text messages and picture messages. All right, it says using your graph, give 2 possible combinations that would work. All we got to do is just pick 2 ordered pairs. It doesn't matter which 2. If I pick 1, 2, 3, 4, 5, 1, 2, 3, that point right there, 50 text, 30 pictures. I'll probably do that in a day, at least, probably. That's one ordered pair. Be another one. Anybody? Somebody, come on. Work with me, people. 5, 3. That's what I just did. So 30 text messages and 50 pictures. So when he said 3, 5, that's 3 on the x-axis up, 5 on the y-axis. Remember, we were going by tens, so that's 30 and 50. Now, so you got to keep in mind the scale that you change your picture to when you're doing those. Technically, 3 text messages and 5 pictures would also work out of that and be in the about right there is where that point would be. But any of those ordered pairs that are shaded in would work as long as they're positive on the X and the Y. No negatives there because we can't have negative text messages or negative picture messages, right? Doesn't make sense to do that. All right, let's try this one. So we got got our feet wet with the word problem. Let's try another one. See if it helps here. I know this more examples with word problems can help you understand how to do them. So let's give it a shot here. Scott's making $12 an hour babysitting and $8 an hour working at the grocery store. He needs to make at least $600 to buy a new computer. And we want to write an inequality for that situation and then graph it. So I'm going to just go out here and I'm just going to say babysitting is X and grocery store is Y. Just pick one of them to be X, one to be Y. It doesn't really matter which one. As long as you know, it's usually, though, the first situation is X, the second one is Y. That's usually the way you want to do it. just so that you're matching up with what the answer keys and things are doing. All right. Write an inequality for this. So let's write an inequality. Why did you choose greater than or equal to? That's correct. At least, yeah, we've seen that already. So the least amount of money we need is 600. If we get more than that, then we can buy a better computer, maybe. So we get that, and we want to graph that. So we're going to get it in slope-intercept form. Factor 12x, get 8y greater than or equal to negative 12x plus 600. Divide everybody by 8. Greater than or equal to negative 3 over 2x plus 7, 4 left over, 75. Negative 3 over 2x plus 75. So again, we got to make a choice about how we do our axis, the x and the y axis on our graph. With 75 being the y-intercept, do we have enough to go by fives? 5, 10, 50, 30, 35, 40, 45, 50, 55, 60, 65, 70. Oh, we do have enough to go by fives. So let's do the y's by 5. And I'm going to do the x's by the same thing, just to so it's easy to graph then. So whatever you set your y-axis to, get your x-axis to be the same, makes it a lot easier to graph. So 75 is our y-intercept. So we're going to go up here to 75. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75 right there at the tippy top. And then negative 3 over 2, it's like down 1, 2, 3 over 2. Down 1, 2, 3 over 2. Down 1, 2, 3 over 2. 1, 2, 3 over 2. I'm just doing that a bunch of times. And it's a solid line because it's got the equal to mark, like Blake told us. And if I plug in 0, 0, is that true? So I can do my shading. 0, 0 is the origin. That's down here. Is 0 greater than 75? No. No. Take it out of here. Said that multiple times, folks. Now, so that's false. 0, 0 gives us a false thing, so that we're going to shade the other side. So our shading is going to be above that line. And so any of these points in this shaded area. And it says, using a graph, give 2 possible combinations of the number of hours that Scott can babysit and work at the grocery store to ensure he can afford his new computer. So remember, X is babysitting and Y is grocery store. So give me an ordered pair that you might want to use there. 20, 5, 10, 15, 20, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65. That point right there. So 20 at the 20 hours of babysitting. And then 65 hours grocery. That one works. Give me another one. Could I do all of my hours on one job? What would that ordered pair be? There's 2 different possibilities there. If I did 0 hours of babysitting, how many hours of grocery store do I have to work to make my $600? Where is 0? Remember, x-axis is babysitting, so 0 on it here is that. Where's the y value that goes with that? What's that number? 75 or anything bigger than that. So if I didn't work at the babysitting at all, I'd have to do at least 75 hours working at the grocery store. That's a lot of hours. I could also, if I didn't do any hours at the grocery store and only did babysitting that month or whatever, what's this ordered pair? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50 hours. 50 hours babysitting and 0 at the grocery store would be another possibility. Why are those answers to this? What would be the case if this was I had to, and if I didn't have the equal to mark, would those 2 points on the axes count if the equal to mark was not there? They would not count because the line would be what? Dotted, and the dotted line means that the points on that line don't count. That's the difference there. Most of the word problems, the equal to mark is going to be in there on most of them. Won't say all of them, but on most of them it is. You'll usually get the luxury of having those points, but don't overthink these too much. They're not trying to trick you too much with that. All right, so let's get into the inequality systems. We'll do a couple of these. It's really just taking 2 inequalities and graphing them on the same coordinate plane. It really isn't anything more complicated than that. So let's do number 1. So I'm going to graph 2 different inequalities. I'm going to graph the first one. I'm going to use my blue pen to do that one just so that we can distinguish between which graph is which. How do I start there? Go to -1, and then my slope is -2/3. So I'm going down 2 over 3. Down 2 over 3. Should that be a dotted or a solid line? Solid, because it's got an equal to mark. So I'm going to draw me a solid line. And then I need to think about shading. Can I test 0, 0 with this one? Okay. Plug a 0 in for y and a 0 in for x. Is 0 less than or equal to -1? No, it is not. So that means I'm not going to shade 0, 0. I'm going to shade away from it, which would be below that line. So that'd be down here. And I'm just going to put arrows on there because I'm going to draw another graph. I'm not going to shade that whole thing. I'm just going to shade the solution area once I get done. So I'm going to graph the second one in red. Where do I start? -8. 1, 2, 3, 4, 5, 6, 7, 8. And a 1/2 slope. They happen to cross at that point there, but it really doesn't matter. It's going to be a solid or dotted line. Solid because it has the equal to mark. Can I test 0, 0 with this one? Yeah. Is 0 greater than -8? Yes. So that means I'm going to shade above this line. Where would the solution area be? Right here where the arrows are all pointing into the same spot, right? So that's the solution area. That's the area I want to shade. So my solution area is this part. Okay. That makes your graphs a lot easier to read. In Algebra 1, you probably did it this way, where you shaded this one like this, and then you shaded the red one like this. And that's a little tough to read when you look at a bunch of them over the day. So I like to just shade the answer area so that I know, hey, that's what it looks like. All of those points in between those 2 lines there in that area are solutions to the system of inequalities. So it really is just graphing two of them on the same coordinate plane. Let's do, trying to see which one. Let's do number 4. It's a little more difficult one, but still not just crazy hard. So number 4, what do we need to do with both of those inequalities? Get them in slope-intercept form. So the first one, I'm going to subtract 7 from both 7x from both sides. And that orange just doesn't show up real good, does it? That's a little better. And then divide by the 3. Keep in mind when you have to flip the symbol or not, so that you're just being careful about that. So I've got the first one in slope-intercept form, so let's go ahead and graph it, and then we'll come back and get the second one. So I'm going to start at 6, and I'm going down 7 over 3, and that's going to be a solid line because it's got an equal to mark. These happen to all have equal to's on the ones I picked to do. Just be mindful that it could be a dotted line. And then I got to shade that, so I'm going to check 0, 0. Is 0 less than 6? Yes. So that means I would shade this one in this direction. Just drawing arrows to say I'm going to shade that one that way when we get time comes. I'm going to work on the second equation. I would subtract 2x. That'd give me negative 3y is less than or equal to negative 2x plus 9. Divide by negative 3. Flip the symbol. Good job. 2/3 x minus 3. Or negative 3 up 2 over 3. This happens to be a solid line. Shading. I could use 0, 0. Is 0 greater than or equal to 3? Yes. So I would shade up toward the origin. The solutions are where the two arrows are pointing in the same direction toward each other. So the solution would be in that region. Again, it looks so much better when you just shade the solution region. I've had students before that use highlighters, and that works pretty good, like using a blue highlighter and a yellow highlighter, and they mix together and make green on your paper. You can do that if you want to, but this is just kind of how I've been doing it the last couple of semesters. I kind of like doing it that way, especially in Algebra 2. Algebra 1, we use the highlighter stuff. But, now, let's get into a word problem or two with this. But first, let's do this, and then we'll get to a word problem. All right, number 7. Which points are solutions to that system? If it's going to be a solution to a system, where does it have to work? In both of them. Can't just work in one. It's got to work in both. So we got to check all 6 of these. It's one of those select all things. So we're going to plug in 1, 1 into the inequalities and decide if it works. If it doesn't work in the first one, you don't have to plug it into the next one because it's already failed. So I'm going to plug 1, 1 into x minus 6y and see if that's greater than negative 48. So 1, 1, 1. Plugging that in. Be 1 minus 6 is negative 5 greater than negative 48. Yes, it is. So works in the first one. I'm going to check it in the second one. 2 times 1 plus 3 times 1. Notice that I did not do the work to get that in slope-intercept form because you don't have to. No, it doesn't help you any. So this will be 5 less than 9? 5 less than 9? Yeah, it is. So far, 1, 1 works. Let's go down that list. So 9, negative 2. So it'd be 9 plus 12. That's going to work because 9 plus 12 is positive, right? Positive is always bigger than negative. So I don't have to really get that number. So I'm going to go to the next one. 2 times 9 plus 3 times negative 2. So that'd be 18 minus 6. Is that less than 9? What's 18 minus 6? It'd be 12. Is 12 less than 9? No. So 9, 2 does not work. So it's out. And then go to the next one. 3, 4. 3 minus 24. Is that greater than negative 48? Yes. So 1 check for that one. Let's go to the second inequality. 6 plus 12. Is that less than 9? No. So that one's out. Next. Negative 2, 6. Negative 2 minus 36. Is that greater than negative 48? Yeah, it is. And then negative 4 plus 18. Is that less than 9? No, that one's out. Negative 8, negative 3. Negative 8 plus 18. Is that greater than negative 48? Yes. All of these have worked in the first inequality, but it seems like the second inequality seems to be the problem. So then the second inequality, we got 2 times negative 8 is negative 16. 3 times negative 3 is negative 9. Is that less than 9? Is negative plus negative less than a positive? Yeah, it's always less. It don't even matter what number that is. So that one works in both of them. And then the last one to check there is 4, negative 7. So 4 plus 42 greater than negative 48. Yes. And then 8 minus 21. That'd be a negative 13. Is that less than 9? Yes. So we get finally find that 3 of these do satisfy that inequality out of that. That's one way of solving this. Another way would be graphing. If you just draw yourself a coordinate plane and graph those two, and then see where those ordered pairs are. I don't think that method is any faster because you got to get both of them in slope-intercept form and then graph them and draw a grid and then shade and do all that stuff. So I really don't think that speeds it up any. I think you're just as quick at plugging them back in to decide that. But that would be the idea would be that you would look at a graph that looks something like this and see which of the ordered pairs are in the solution area that are listed. That's one other alternate way of solving that. Not the way that I would probably go about it, but it does work. All right. Let's do a word problem. To raise money to attend Boy Scout camp, Alec is selling popcorn. Small bags of popcorn sell for $4 each, and large bags sell for $6 each. He needs to earn at least $300 to attend camp. He will also earn a badge if he sells at least 60 bags total of any combination. So we want to write a system of inequalities to represent the situation and graph those. So I'm going to call the small bags X. So small is X and large Y. It doesn't really matter which one you do that with, but the small one was listed first and the large was listed second. So that's how I'm going to do that. So we're going to have two inequalities to deal with here. One of them deals with money, and the other one deals with the number of bags we've sold. Okay, so there's two sentences there. One of them deals with the money, and one of them deals with how many bags total that we've of any combination. So let's do the money inequality first. $4 for small bags, $6 for large bags. So what would be the 4x plus 6y greater than or equal to 300 because it said the word at least. Okay. We're going to end up having to get that in slope-intercept form. We'll get there in a second. The second inequality has to do with how many bags we've sold. We want to sell, we get a badge if we sell at least 60. So what would be our inequality for that? I know at least 60 is going to be greater than 60, right? We got that part. What's on the other side there? Any combination of bags. How small or large, doesn't matter which ones, but we're probably going to sell some small bags. We're probably going to sell some large bags, right? We don't know how many of any of them, right? So, but we just got to sell 60 total. How do you total things in math? Add them up. So small bags plus large bags is a total, right? Those are our two inequalities that we're going to graph on that graph over there. So we're going to get them in slope-intercept form. So subtract 4x. 6y is greater than or equal to negative 4x plus 300. Divide by 6. Y is greater than or equal to negative 2/3 x plus 50. And then on this other one, we're going to subtract x, and that's all we're going to have to do. Negative x plus 60. All right, so we got two inequalities that we're going to graph on this coordinate plane, but we need to set a scale on this coordinate plane. Make it easy to graph. Look at our y-intercepts. That's how we're going to decide. 60 and 50 are our y-intercepts. What would be a good number to go by on the y's? 10s would be easy, right? Because 10, 20, all 50's right on there, 60's right on there. I think that'd be a good idea. So let's go by 10s. So y's by 10s. I'm going to do the same thing on the x's by 10. So to graph the y is greater than or equal to negative 2/3 plus 50, I'm going to go to 50. 2, 3, 4, 5. Down 2 over 3. Down 2 over 3. And it's going to be a solid line. That's right. Shading. I could do 0, 0. That's right. Is 0 greater than 50? No. So I'm going to shade above that line. I'm just going to put my arrows on it. Then I'm going to go and graph the second one. Its y-intercept is 60, just right above that with a -1 slope. Crossing. Again, that's a solid line. And then shading is 0 greater than 60. No, so I'm going to shade above that. So the answers are in this region. Now, we also know that we can't sell negative bags of popcorn, right? So we know the answer when it asks for B part, give the two possible combinations. Neither of those can be a negative number, right? That makes sense, but in the context of a word problem, we can't make up negative popcorn bags. So Give me an ordered pair. Say that again. 8, 1. So 8, 1. 8. So right that point right there. So that'd be on our X. That'd be 80 small bags and 10 large. That's one solution. Give me one more. Two, 1, 2, 3, 4, 5, 6, 7. Right there. Right there would be 20 small and 70 large. Both of those are going to get us more than $300 total, but that's what we want, right? The least we wanted to make was 300 out of that. Yeah, I know. Battery's about dead. Okay. All right. So we've seen some word problems. We've seen the idea of how to work these and get somewhere with those. I think this one is very similar. You got 28-cent and 4-cent stamps. I would call the 28-cent stamp X and the 4-cent stamp Y, and then go from there. And you could do that one if you wanted to do that one together or on your own. That's fine.